Hello everyone. Let's verify if inverses, but this time without using composition. So, as I said in previous videos, to verify inverses we use composition, and then each composition, F composition G and G composition F, both need to be equal to X. But we can actually verify inverses in a different way. We can, let's say, find an inverse of this one, of f of x, and then compare it to g of x. If they are the same, then the two functions are inverses of each other. So let's try that approach. So y equals to 3 half x minus x. What I did here is just replace the f of x notation into y, so we can switch y and x, because remember, that's how we make an inverse. We make x and y change places. So now y becomes x, and then this x right here becomes y, and then we still have minus 6. So now all we need to do is solve for y. So we add 6 to both sides. We have x plus 6 equal to 3 halves y. A quick way to actually make the next step is, and get y by itself, is to multiply both sides by the reciprocal of this, which is 2 over 3. Multiply this one by 2 over 3. And then what happens is this 3 and 3 and 2 and 2, they cancel each other out, divide each other out. So y would be equal to 2 over 3 x plus 6. Now, one thing about verifying inverses this way is this. Like, we got y equals to this right there. And we need to check if this is same as, so we need to check if this, the inverse, this is actually our f inverse of x, if that is actually equal to our other function, which is g right here. Well, if we just leave it like this, we might actually make our own conclusion, and that's the bad thing about this approach. So we need to be careful. But see, since we have these parentheses and all of that like that, it obviously doesn't look the same as g of x right here. So we need to try and play with this one a little bit more and see, can we get it to look like this, right? So let's try that. So one thing that we can definitely do is get rid of these parentheses, because obviously our g function doesn't have parentheses. So we'll get rid of parentheses by doing the distribution here. And I'll start with y. Actually, I'll start with f inverse of x being equal to, and now when we distribute the 2 over 3, we get 2 over 3 x plus 2 over 3 times 6, right? Now this is starting to look much more similar to what we have there. And then let's go ahead and simplify this part. So this is 2 over 3x, and then plus, this is 6 divided by 3 is 2, times 2 is 4. Now this really looks exactly the same as this one right here, right? Which means we can conclude that the two functions are the inverses of each other, right? The two functions are inverses of each other, right? hope I spelled this correctly. Okay, so this is another way to verify inverses, but as I said, we need to be careful because we might end up with something that really is equal to our other function, but doesn't really look like it, and we might make a wrong conclusion. So we always need to, once we get the y by itself for our inverse, we need to try to play with it some more and try to match it so it looks exactly the same as the other one. Now we could have done this first. Find the inverse of this function g of x and then see if it looks the same as the f of x. So it doesn't matter which function we pick, as long as we do everything correctly and as long as we are careful at the end that we don't make a conclusion too early and make a mistake. So we need to kind of really pay attention to that, play a little bit of a matching game. And in this case, the matching really worked out, and we say, well, they are actually inverses of each other. I hope you liked the video. If you did, please click like, subscribe, and don't forget to smile.